Hello, and welcome to the next module of Universal Application Development on Windows Platform course. So last time we have seen an example of sorting an array interactively in our user interface. So the way it was done is we have declared some collection. To begin with, we used an array of integers. We declared it in our page, and we showed it on the screen using ItemsControl element. Or I think last time we used listbox, but we can use the similar element called ItemsControl. So in order to show our array on the screen, we used the concept called data binding. First of all, to show the whole collection, we used this construction, data control dot item source equals to data, where data is the actual array. And with this one line of code, we assigned the whole array of numbers to ItemsControl, and we were able to display it on the page. We did not need to copy each individual value from the array and put it manually inside the ItemsControl. Second time where we needed data binding is we used item template to specify how each element of the array would be displayed. And we decided that each element would be displayed as a rectangle, and width of the rectangle would be automatically bound to the value of the array. So this special syntax width equals to binding means that this property would be taken at runtime from some data which lives inside our application. So those two examples show data binding. Now let's talk about data binding in a little bit more detail. So let's try to do the same task in a little bit different way. Instead of assigning item source directly in our code behind file, let's do it via data binding as well. So in order to do this, we use this construction here. We say item source equals to binding data. And if we want the data to be updated automatically each time when we change something inside the collection, we specify mode equals to one way. One way meaning that whenever we change something in the at the runtime in the C# code, it is reflected in the user interface. Then, in order for this to work, we need to make sure that this variable data is a property. So it's important that it's not a field, it's not just a variable, it's a property, and it's a public property. So data binding works only on public properties. That's important to remember. And also, in order to automatically update the user interface, we need to make sure that this data object is smart enough and it can signal the user interface whenever it's updated. So if it's just an array, like in the simple example, it would not happen automatically because there is no way for us to know when the array is updated. So in order for this to work, we need to use a special data type called observable collection of int. And this observable collection is a very smart collection. Whenever we specify data binding, the user interface, in this case ItemsControl, can subscribe to events when the collection is changed. And the collection would signal those events, and those events would cause the user interface to be updated. We'll talk a little bit more about how this works shortly. And we have seen this example already, how this works with data binding and how this all is handled automatically. So let's summarize. There are two ways to show data in the user interface. We have the separation, as you know, between XAML layout and C# code behind code. So one simple way to show data in the UI would be to directly assign something to the properties in C# code, and it would be reflected in the user interface. And another way would be to use data binding. And when we use data binding, it's very common to separate all properties inside one file, which is called a view model. So in this case, it would look in the following way. In our code behind file, we will create the view model object. And we will say that data context of the current page is this view model object. So whenever we specify a property for data binding, it would not be relative to the current object, it would be relative to the view model. And the view model would contain all the properties for all the data which we need to be displayed on our page. So for example, in our example with temperature, with weather application, we would have the public property called temperature. We would have the public property called image. And the view model would contain all the logic. And the page would just be data binding, would just have the data binding code, which binds view model to the actual page. Let's see how this works. So let's come back to our weather application. I would remind you that in our weather application on the main screen we had temperature and the icon for the current weather displayed from OpenWeatherMap. So in our case we have the text block and bitmap image. And all those fields are populated in the code behind file. So if we want to move it to data binding, we would move all the logic away from the main page. So I would just erase all the logic code and I would put it in the separate class. So I would create here a new class called, for example, weather view model. I'll make it a public class. And then in this class, I would have fields corresponding to UI elements of my application. So in this case, I would have the field called temperature for the temperature, and I would have the field called peak for the image. And the main work in my code would be done using the load method. So I would create the public async load, which would load all the elements from the internet. And I'll just copy the code, which is basically the same as in my application. I'll create new HTTP client, then get the string using the JSON to decompose it, and then load the bitmap image. So that would be the code, and this code would load all the elements. And now in the main page, I will do the following. In the page loaded, I would call the load method. But before that, I would create the class here. I would say weather view model VM equals to new weather view model. And in the main page, I will say this dot data context equals to VM. And here I would say VM dot load, and because it's async, I would use await. So you see the logic inside my class is very simple. I just instantiate the data context, and I will do all the data binding in the XAML file. So because I know that my temperature text field should display the temperature, I would say here that in image, I would say source equals to binding peak, and here in the text blocks I would say text equals to binding temperature. Let me just check the names of the files, peak and temperature, exactly. So that's how it's supposed to work. But let's see if it works. I will start my application. And hopefully we'll see it in a minute. Yeah, I think there are still no data on the screen. So why could this be? Well, first of all, you see that we call the load method after all objects has been loaded. So one of the things we can do to fix it is to say load the data here before. But that's not a good way to do it because data can be loaded asynchronously after the page is instantiated. So ideally, our application should know when the data is available and it should update the user interface. In order to do that, I will remind you that we need to set binding mode to one way, because by default the binding mode is one time, so it's done only on object creation. So here also we'll say mode equals one way. Let's now see if it helps. I will start my application. It would also take a little bit of time to load. And what we will see is that data is not available either. Why does this happen? Because as we said, the user interface has no way to know that the data has been changed. So we need to provide additional ways for it to know that the data has been changed. And in order to do this, I will implement a special interface. This interface is called iNotify property changed. It's a little bit long name, but it's very important. So you see it resides inside system.component-model. So I would implement this interface. And now I would say implement interface. And you will see basically I added one event called property changed event. So what it means is that whenever user interface wants to subscribe to changing the data, whenever I specify data binding, it would add to this handler something which would track the changes. And I would need through this property to notify whenever I change some data. So for example, in this load, I can do one thing. I can check whether this property changed event is not null. And if it's not null, then I raise those events, specifying the field name which I have changed. In fact, when I called load, I changed the temperature and I changed peak. So I raised this event twice, saying that I have changed property called temperature and I have changed the property called peak. And by the way, another thing we absolutely need to do is to change temperature and peak to be really properties and not variables, because otherwise data binding would not work correctly. So now that we have implemented the property changed event, I would run this application and see if it can correctly fetch the temperature. You see that when the application first starts, it firstly displays, the temperature 0, and then when it's loaded, the temperature is changed and the value is automatically updated. So there is one small thing I still need to improve this to make it ideal, is that whenever I set the property, I would need to automatically call notify property changed event in this set handler. So I would need to make it a little bit more verbose. For example, I would say private int temp, which would be a variable. And then I would make temperature a real property, saying that get would be a property which returns temp, and set would be temp equals to value. And here I would need to raise the notify property changed event. So I would call a function, for example, I would call it notify, and say here temperature. So in this way, whenever I change this property, it would automatically raise the notify property changed event. And this notify method would be pretty simple. I would basically check if notify property changed event. I'll basically copy it from here. If property changed is not null, then I would call property changed of v, of this and v. So here I can simplify a little bit my code. I would just basically delete this altogether, and it would happen automatically. Whenever I assign temperature to be equal to x.main.temp, it would automatically raise the event. And I would need to do the same decoration for the peak. I would say private bitmap image called peak. And then here the getter would return peak, and the setter would say peak equals to value and notify peak. So that's how we typically define our view model. And now this view model contains automatically this view model automatically contains all the logic for the application. So let me check just what's wrong here. If property changed not equals to null, then we call property changed with new property changed event args of v. Yeah, it's a little bit more complex. We just need not to specify the name, but the property changed event arguments. Let's run and check if it works. See, it works basically exactly the same. But now we have made the code in such a way that we can make changes to the properties, and we don't need to track manually all the updates. All the updates would be automatically notified to the user interface, and user interface would update only those elements which has been changed. So that's quite convenient. And by the way, you see Visual Studio allows us the easier way to write it, but I don't think this way is too beautiful. So let's summarize here. The way we create applications using ViewModel is called a specific pattern, Model-View-ViewModel, or MVVM. So MVVM typically consists of several things. First of all is the model. The model is basically a number of objects which represents our business logic, our domain model. So in our case, it would be, in case our application is more complicated and contains series, it would contain the list of series, it would contain different elements. If the weather has historic data, it would contain some sequences and so on. So the model would be a set of classes through which we can get access to the data. It can get access to the data through the internet, or it can contain data in the files. It doesn't really matter. What matters is that model can represent our real-life objects on which our application, with which our application works. Then, for each screen, we create view models. So, view model is basically a number of properties which reflects a particular screen on the of the application. So, in our case, when we have this main application view, when we have temperature and we have picture, our view model would contain two corresponding fields. And to get the value of those fields, we would need to ask the model. In some cases, like in our example, view model and model was basically the same thing. It was just one file which did everything, because our example is very simple and we don't really need to two separate files, two separate entities. But in most of the cases, model is more complex, and view model is the reflection of this model through a particular user interface. And then there is also a view, or the user interface, and view defines how the data is displayed. It's basically XAML file with some data binding. And the code behind contains minimal changes, minimal code. It's basically just instantiating the view model and setting data context to it. And this allows very clean separation between code, logic, and presentation. It also allows to test view models and models very efficiently, because if you want to do model testing, you definitely need to cover through these tests, you need to cover how the application works, and this can be done through view model. So basically you can see how view model behaves, and you can test this, and then when you attach it to a view, you can expect the application to work. So for complex applications, MVVM pattern is a very good thing. But if the application is simple, you can see that the amount of code increases. Application gets more complex, but without any visible changes in functionality. So if you want to design an application, you need to think first whether it would be really big application which you would need to maintain for a long time and for which you would need to create an extensive test coverage. And in this case, I suggest you would use MVVM pattern. But if your application is rather simple, then MVVM can be a little bit of an overkill. So to summarize how data binding syntax works, data binding can be quite complex. You see that you can specify, for example, converter, which would show how to convert values from internal C# types into textual representation. For example, if you convert currencies, or if you can convert RGB values to colors or something like this. But most important parts of data binding is, apart from converter, it's also mode. Mode, as you know, can be one time, which means data binding happens only once on the application startup. It can be one way, meaning that it would reflect all the changes automatically whenever they are changed and notified from the code behind. Or it can be two-way. Two-way is useful for elements such as text box, which you can edit. It can be useful for like drop-down lists or checkboxes, because this allows the UI element, when UI element changes, to signal changes back to the code. So data binding works both ways. Again, let me explain one more time how the field knows when to update it. In the XAML layout, first of all, we need to specify that mode is one way, so that it's not one time. And in the code behind, we use iNotify property changed. iNotify property changed is an interface which specifies basically one this public event field. So all classes which implement iNotify property changed, they have this property changed event handler. So this property changed event handler allows us to subscribe to changes in the logic. So whenever you do binding, whenever text block binds to temperature, it subscribes to changes to property changed handler. And it checks when property change handler is called with the corresponding name of this property of temperature. It knows that it needs to refresh it and draw itself again on the screen. Then for each property, for example, for temperature, we need to explicitly call notify function to show that the property has been updated. And in the notify function, we check just to make sure that property changed is not null. And if it's not, we call it. And we specify this field name, which is in our case temperature. So that's how ViewModel typically works. And of course, that seems like quite a lot of code. And there are some frameworks which allow to write less code. It allows to simplify writing this tedious automatic notifications. But still, it's not automatic. It's some additional work. Whenever you use MVVM, you can expect the code of your application grow like 20-30%. In fact, there are two interfaces, not only iNotify property changed, there is also a collection called iNotify collection changed. Because whenever you have a collection of elements, you need to also make sure that you notify when some operations are done to its elements. So if you want to bind like drop-down boxes or list boxes to a list of objects, then you can simply, then you need to use a collection which implements iNotify collection changed. And luckily, as we have seen already, observable collection is such a collection which you can use just instead of list or instead of array, and it would automatically handle updates. Now let's add some displaying of collection to our example. In our example, let's implement weather forecast for a few days. For weather forecast, we would take an icon for each of the upcoming days, and we would take temperature. And those two things would be represented by a class called weather record. So weather record would basically contain two fields, temperature and icon. And the list of such records would be stored in observable collection. And to show it on the screen, we would use grid view. Grid view is a very nice element which allows to display a collection of elements in a grid, similar to the way application icons are displayed on the start screen of Windows or Windows Phone. And here we can also specify data template, which shows how to display each element. And in the data template, we would specify data binding. We can bind image element to icon and textual element to temp, so that it displays correctly temperature and the icon. Let's see how it works in the code. To begin with, we will add specific class for a separate forecast item. I will do it right in the view model file, but it would be a good idea to do it in a separate file. So the class would be called weather record, and it would contain basically properties: temperature, pressure, humidity, the date time when this took place, the icon, and then I will specify two additional properties, calculated properties. So for the date, it would specify just a short format of the date, so it's day and month, and then full date would be like a long specification of the date, like January 1st. So it would be a very simple class. I would not create a constructor. It would act like a structure. And then we will display the forecast for a separate for a few consecutive days. And to hold it, I would need observable collection. So I will call it forecast. I would create a public property, so it would be public observable collection. And let's make sure that using statement is in place so that it's resolvable. So observable collection of weather record, and I would call it forecast. And as I said, it should be a property, so I would make it I would add getters and setters, and I would create it right here, a new observable collection of weather record, so that I don't need to take care about creating this at some point later. So this forecast would be a collection. Now in my load method, I need to retrieve the data. If you remember, load retrieved the picture and temperature, and here I would add some additional code to retrieve the actual forecast. So retrieving forecast is quite simple. We also call some URL, and this URL is basically the same, openweathermap.org, for Moscow, and I would say that for 7 days. So CNT equals to 7 means for 7 days. Then it's also returned in the JSON format. I deserialize it, and for each element, I basically add it to the list. So I probably mistyped the name forecast, or I added it to the wrong class. Yes, it should be in the Model-View-Model class. Sorry about that. So it would be here. And below in my load method, what I need to do, whenever I add something to forecast, I create new weather record class, and I take the data from the JSON file. So temperature, pressure, humidity, I load icon here, and the only problem is that date is specified in the different format. It's basically UTC time, so I need a special function to convert it. So I basically add the special function here for everything to work properly. Because it's just a long time, it's Unix time from 1970. So I create this starting time and then add corresponding number of seconds to that. And that would give me the data in datetime format. So this should load my forecast with corresponding data. And now what I need to do is I need to alter user interface of my application. Please note that I don't need to change anything in the code behind, because the code behind always stays the same. I just do data binding and load the page. And in the main page, I would need to add additional elements to display the forecast. So I would call it grid view. And I will bind it. So items source would be binding forecast. And that's it. Let's see how it works. I would just start my application. And see if I can really get the values to show. Probably you realize it would not be quite beautiful because we have not done anything to the design. So you see the temperature loaded, and now here is the grid view, and in fact it shows records. You see, it's each object is open weather map weather record, but it's not displayed beautifully. Why? Because grid view does not know how to display it. To display it properly, I need to specify the data template here. So I would use grid view item template, and then data template. And for each item, I would need probably an icon and the temperature. So that would be a stack panel. To make it faster, I have already created this stack panel. That's how it would look like. It would specify the temperature, the date, and the picture binding icon. Now let's see how it works. You see the temperature appears first, and then the forecast. We see the forecast for the next few days. Unfortunately, it's going to rain a bit, but that's okay because the sun is there as well. So you see we have quite nice looking application, and what's the nicest thing about it is that the code is beautifully separated from the actual markup. In addition to binding, traditional binding, there is also a new way of binding in Windows 10 UWP, which is called static binding. So static binding is specified using xbind instead of binding, and it's a compile time binding. So this binding happens in compile time. All the names are checked at compile time, which is much better because it acts more like a static typing versus dynamic typing, because you can automatically track all typos. It's strongly typed, so you should know all types of all fields. By default, it's one-time binding, not as with traditional binding, but there are also traditional one-way and two-way, which are also supported. And you can also xbind to fields and variables, not only to properties. That has to do with static nature of binding. It can resolve the name at compile time and find the appropriate object. And you use identify property change, observable collection, and so on in the same manner as you do with traditional binding. Let's see how you can apply dynamic binding in the case of our weather application. Now let's change our application to use static data binding. So what we need to do that is basically change each binding for xbind. So I will say here xbind pick. But you see, instead of pick, we need to specify the view model, because VM is the variable inside our application. So I would say vm.pick. For temperature, I would also say xbind vm.temperature. And for the template, I would say xbind icon, xbind temp, and I would say xbind date. So that should be it. When I compile, I would see that there are some errors. You see, no data type is defined for data template. One of the drawbacks of using xbind is that the compiler doesn't have any way to know which data type would be bound to this template. So I need to specify it explicitly. I would have to say x data type here, and I would use local weather record. So local is the local namespace of this project. You can see that this namespace is defined here. Local is open weather map simple, and weather record is the class inside this namespace. So I specified the class, and now I can compile the application and see how it works. And probably we will not see any difference because the application is basically the same, but data binding works faster, and it's more safe because we check types at compile time. For example, if I mistype the field name here, I would get an error at compile time. While if I use static binding, it would only be discovered at runtime, and the field would be empty. So it's very easy. It's much easier to fix errors using static data binding. Let me reiterate once more the differences between two bindings. First of all, you need to specify the precise name of the field. So it's vm.forecast. Then you need to specify data types if you are using it inside the template. And otherwise, it's basically the same as traditional binding. Here you can see the difference in terms of performance between static and dynamic binding. So compiled binding here below uses this amount of time to do the data binding, while for static binding you can see that's the amount of time it takes to display the user interface, which is definitely much longer time. So to conclude, data binding allows you to further separate code and behavior. And this is very good because you can have different developers working on different code. The code is in different files, so you can check in and check out them separately, and you can do unit testing. So the same view model actually can be used for structurally different UXs. For example, if you are doing UX for the phone and for the desktop computer, you can create separate views, but you can use one view model behind them. And using MVVM requires more code, as we have seen. It's from 20 to 30% more code. And for really complex project, you should definitely use MVVM. And for a simpler project, you can probably use simpler method, just assigning variables. But it's always a good idea to use data binding even without MVVM. You can bind to collections, and that would save you a lot of code.